Okay, there are 4 cases, and those are the cases we'll do today, probably case 1 only, and we'll do the rest of them tomorrow. Case 1, Q of x has linear factor. By that I mean exclusively, only linear factors. Okay, case 2, Q of x has repeated linear factors. Case 3, Q of x has some quadratic factors. And case 4, Q of x has some repeated quadratic factors. Okay, so the repeated, if I don't say repeated, then I mean distinct. Each one is a different factor. So by linear factors, I mean each distinct linear factor. By some quadratic factors, I mean you have some distinct linear factor and some distinct quadratic. Otherwise, it's repeated. So now let's go and do the first case, case 1. And we have only linear factors, and this will be only distinct. So for this case, let's pick up example 2. Actually, before we do that, before I write the example, let me tell you what's going to happen. So in this case, what Q of x can be written, the polynomial can be written in general as a product of linear factor a1x plus b1 times a2x plus b2 times dot 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 a sub k x plus b sub k. In other words, there are k distinct linear factors that make up whose product is the denominator. Okay, so what are we going to do? We're going to use that to write either, let's say, if it's a non-proper rational function, then we look at the remainder divided by the denominator. We're going to break it down into the following. We're going to break it down to a sub 1 divided by a sub 1x plus b sub 1 plus a sub 2 divided by a sub 2x plus b sub 2 plus dot 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 a sub k divided by a sub kx plus b sub k, where uppercase means the numerator of each of the partial fraction and the denominators, the factors, are denoted with lowercase. All right? So this is what we mean sum of partial fraction. So we need to break down the polynomial, the rational function, into sum of partial fractions. So here we go with the example. This will be example 2, and where we need to evaluate the integral, and we have a numerator that looks like x squared plus 2x minus 1. So this is the numerator is second order polynomial, and the denominator is 2x cubed plus 3x squared minus 2x. So second order divided by third order dx. So this is a proper rational function. So we don't have to do long division in this case. Okay. So as far as step 1 is concerned, sorry, let's write the solution here first. So So what is the solution? Go through the steps. Step 1, we need to verify that this is a proper rational function, and it is correct. N is less than m, and therefore the integrand x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x is a proper rational function. So we are done here. Let's look at step 2. Step 2, we need to factor the denominator. So q of x equals 2x cubed plus 3x squared minus 2x, and we see right away that we have a common factor, which is x. So we have x times 2 times x 2x squared plus 3x minus 2. And if you want to factor this trinomial, well, to get to 2x squared, we need to multiply 2x by x, right? Negative 2 can be obtained by multiplying 1 by negative 2 or negative 1 by positive 2. Okay, so, and I need to have positive 3x in the middle, so I'll multiply 2x by 2 to get 4x, and then here I have negative 1 to get to 3x. So we factor it as x, 2x minus 1, and x plus 2. Those are the three linear factors. X is, in fact, is x minus 0 as a linear factor. So at this time, I'm ready to go to step 3 and write it as a sum. So x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x can be written as the following: a1 over x plus a2 over 2x minus 1 plus a3 over x plus 2. Okay? So here we are. Now, what do we do next? By the way, this is what we call the partial fraction decomposition of the expression to the left. Partial fraction decomposition of this term, of the integrand. So what do we do next? We really want to find out the values for A1, A2, and A3. That's the name of the game here. So we're going to start by multiplying everything. This is an equation. As a matter of fact, this is an identity. And on tomorrow, I'll show you how we use this property, that the fact that we have an identity here. This is supposed to be correct regardless of the value of x, for any value of x. So that's why I said this is an identity. So what we're going to do is multiply this identity. So at this point I'll call it equation, but in parentheses I'll write identity, and I'll address this tomorrow, by the least common denominator. Okay? LCD. So what is the LCD? Well, the LCD, since we have three different factors, and we don't have a case where one factor is a factor of the other one, then the LCD would be simply the product, x times 2x minus 1 times x plus 2. So what happens if we do it? Well, we lose this equal to that, right? This we just factor, so we lose the denominator. On the left, we have just the numerator, x plus 2x minus 1. What do we have on the right? We have a1 over x, right, times x times 2x minus 1 times x plus 2. But a1 over x times x, well, the x are reducing each other. So we'll have a1 times only 2x minus 1 times x plus 2. What about a2? Well, A2 is divided already by 2x minus 1. As we multiply by the LCD, the 2x minus 1 and the 2x minus 1 cancel each other, so all we have left is x times x plus 2. 5-minute warning. Okay. So now for A3, A sub 3, once again, we have a sub 3 divided by x plus 2, so we lose the x plus 2, and all we have is x times 2x minus 1. Okay? Oops, I went to the next page. 2x minus 1. That's so. The next step is solving for A1, A2, and A3 by a technique called comparing the coefficients. Okay, on the left side, we have 1 multiply x squared, 2 multiply x, and negative 1 multiply 1. So the coefficient of this trinomial on the left will be 1, 2, and negative 1. Right? Now, when we clear the parentheses here, we have something multiplying x squared. That something has to equal to 1. We'll have something else multiplying x. That something has to equals 2. And then we have the free coefficients. Those have to be equal to negative 1. So by comparing the coefficient, we can solve for A1, A2, and A3. Make sense? So the next step is comparing, multiply or clear parentheses and compare coefficient. Let me do the split here. Okay, so I don't have to hold 2 pages, like so. But I need to look at it as well, so you can see it. So clear parentheses, and compare coefficients. Okay, so as I said, what do I have on the left? Of x2, x, and 1. Okay, so let's see. On the left side, we still have x squared plus 2x minus 1, right? What will be the coefficient that multiply x squared? Let's look on this side, on the right side of yours, and I'm looking here. Are we done? Actually, can I undo the split page? Okay, so let's look here. What will be multiply, where are we going to get x squared? Okay, we have 2x squared, so we have 2x squared times a1, right? So it will be 2a1 from the first expression. The second expression, we have a2 times x squared, right? So we have plus a2. And in the third one, we have x times 2x times a3, so we'll have 2a3. So those are the coefficient of x squared. What are the coefficient of x? Okay, here we have 2x times 2, that's 4x, and then negative 1 times x, that's 3x. So we have 3x multiply a1, or 3a1. What do we have from the mid-center term? We have a2x times 2, so we have 2a2. And the last one, we have x times negative 1, so a3x times negative 1, or negative a3. Those are the coefficient of x. And what do we have as free coefficient? The only time we don't multiply by x is the first product. We have a1 times negative 1 times 2, or negative a1. Okay? And we'll write it negative a1 times 1. So we have a coefficient of x squared, coefficient of x, and coefficient of 1. And now we compare the coefficients. So, as we compare the coefficient, we're going to generate a system of 3 equations, or 3 by 3 system. The coefficient of x squared on the left is 1, on the right is 2a1 plus a2 plus 2a3. The coefficient of x is 2 on the left, and on the right we have 3a1 plus 2a2 minus a3. And the coefficient of 1 on the left is -1, on the right is -a1. Is it 2a1 or? It should be -2. Let's see. It should be -2a1. Let me go back and look here. It's 2, let's see, -1 times 2 times 1, so it's -2. So here we have -2a1, so it's -2a1, like so. Okay, so this is a system. You can solve it by however you want. I'm going to jump to the solution. We can solve by solving first a1. a1 will be 1/2, and then multiply the second equation by 2, get rid of the a3. You want me to show you how to do it like this? Do we have time for that? We're already past the time. On the other hand, we have the system, and this is something that you can use in your graphing calculator. I really like you to solve it by hand, but the system will be 2, 1, 2, 3, 2, -1, -2, 0, 0, a1, a2, a3, and on the right side we have 1, 2, and -1. Okay? So, the solution. A1 is 1/2, A2 is 1/5, and A3 is -1/10. So, let's bring it home. So, what is the integral? The integral I originally was x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x is now equal to the integral, and we have 1/2 times 1 over x plus 1/5 times 1 over what was the other one? The second one, 2x minus 1, right? Plus, minus 1/10 times 1 over x plus 1 dx. Okay, what are the antiderivatives? 1/2 natural log of x. This one I may need to explain, but the result here, if you do u substitution, you let u equals 2x, and du or dx equals 1/2 du. The result would be 1/10 natural log of 2x minus 1. And this one will be minus 1/10 natural log of x plus 1 plus c. And notice these two components have 1/10 and 1/10, but here we have natural log of 2x minus 1 minus natural log of x minus 1. We can simplify it. Please do simplify and get plus 1/10 natural log of 2x minus 1 over x plus 1 plus c.